Okay, I think we're going to do some unplanned streaming work here. So let's hop right into it. So I was going to clean up some contracts. I guess now might be the time to say what we're working on. Actually, you know what? I'll let the contracts speak for themselves. These are some old contracts I wrote. I didn't really write them the right way. There's a lot I didn't know when I was writing them, so we sort of need to fix them up. So let's just make a new file, and we're going to work through these probably a bit one by one. Okay, so you see this here is called the user contract. It's going to handle some user logic. I tried writing two contracts on the same script. I don't think that's a good idea. Like, you see contract, user contract here, and then you see stand master over here. So we're going to work on stand master first. Just give me 1 second while I save this. Oh wait, that wasn't what I wanted to happen. That wasn't what I wanted to happen. Right, because it's that. There we go. Okay, we're going to call this master.sol. Sorry, and of course I need to bring you all back online. Alright. This is the style I've been seeing for writing the pragma solidity recently, so I'm just going to pull it straight off of there. What else do we have? We're going to need that at some point, but we're going to have to turn it into an interface, so I'm going to leave that off. So I'm going to leave the import out for right now. I might be going a bit fast on the solidity stuff. It could be I need to slow down, take a little bit of a break. Just explain myself a bit better. But I guess for now, I'm just going to try and explain what I've got as I go. Now we have this. You know what? I think I'm going to line by line this just to make sure I still really agree with myself. So we have contract. This is going to be a master contract that stores logic for a platform. So we're going to have an array of addresses for users, public users. Another one of artists and unknown projects. I'm going to take a guess, actually, that I can consolidate these into one and leave it like that. You may have guessed it's supposed to be a platform that sort of lets use... wow. As you can tell, I came prepared with my elevator pitch tonight. The basic idea is building communities around artists and projects. So, yeah, I believe when I originally started writing these contracts, I figured they needed to be discrete, like, you know, two different things. But I'm really starting to believe they could be one thing. And there's a good chance I'm going to even jettison this name for something else, though I'm not exactly sure what. Then we have an enum for types. Types. Usually these go. Okay, and enum, of course, this is going to let me use these types with regards to accounts and sort of determine what their type is. Mapping. This is where I do the types, right? Address to type, type of. now I have a pile of events. You know what? I'm going to trust myself on the events right now. I'm going to copy paste them, but then I'm going to read through them. So we have an event for the creation of the contracts, which gives us the contract address and the time, creation of a user. Okay, creation of a user, how does that work? So I seem to remember the way that I had this wired up before is each user is going to have sort of a contract wallet, but that's going to be generated by a EOA, an externally owned account. As in, again, in Ethereum, there are two different kinds of accounts. There's basic user accounts, and then there's contracts. So whenever you make a contract wallet, that contract wallet needs to be generated by what's called an EOA, externally owned account, which is a user account. It's an account that doesn't have contract data in it. So over here, if we want to give users sort of a contract wallet, it needs to be generated by an EOA. That's the root. The user is where the contract wallet would be. String might be the name to be associated with that and the time of creation. User removed or deleted. Of course, removed doesn't mean that they actually get removed from the blockchain. That can't really happen. That's why we have the deleted type over here. We're going to want users, if they delete their account, the account will still exist, but they're going to have a deleted flag there. Artist created. So again, I see here that I kept artists and projects together. I think I'm going to consolidate these and just call it an art proj for now. The difference between an artist and a project is if it's recurring or a one-time thing with a deadline. Wait, do you want that space? Okay, web. That's not what I wanted to do. So here I have modifier only user. Let's take a look at this. Modifier user. Does that need to be in the master though? I'm not sure why these are. Oh, okay. Because it wasn't a factory contract. It doesn't generate the other contracts. Okay. Only user. Those. So what modifiers do is you'll see that modifiers, I didn't explain events or mappings. I wonder if I should have slowed down and explained those too. The mapping actually is visually pretty self-explanatory. It takes one thing and maps it to something else. Then you're going to have a dictionary here where all of the key values are addresses and all the key pairs are addresses and all the values are types. Which allows us to have basically a phone book here where you can put in the address of a user and find out what type they are. Like if they're a user, if it's an artist or project, or if it's a deleted account. So events, you'll see, are things that fire off sort of as an alert, I guess you could say, when certain things happen on a contract. The nice thing about events is that they're cheap, as in running anything on the blockchain in general is expensive, but firing off events is cheap, reading events is cheap. So they're a very useful way of broadcasting information, especially about certain things that are happening. Like, if the contract is created, it'll fire off an event. New user is created, fires off an event, etc. Modifiers are an easy way of restricting access to a function. As in, we're going to have functions that we only want a user on the platform to be able to call. So what's going to happen is we're going to write some kind of function at some point, and then we're going to put over here only user. Yeah? And that will make sure, we hope, that only users of the platform will be able to use this function. So type of message.sender equals, actually it should be a not equals, right? Okay, I see what I did. Types dot user. So what this would do is it checks that message.sender is a user. So this means that really only a user can use it. Even an art-proj contract wouldn't be able to use it because it would have an art-proj type. Yeah? This ensures that the type is user. As it happens, if I wanted to say that also an artist or project could use it, I could put the or bars over there and then also add in type of message.sender equals types dot artist or project. I could also do that. For right now, I'm going to trust myself that I had some reason for only restricting to user. Oh, right. So that actually is supposed to be a comma. And then I had a error message. This is the error message that'll come up if someone who's not supposed to use this uses it. Okay, and then a little bit of the cryptic nature of modifiers. This over here, the underscore semicolon. What it does is it tells the function to keep on running. So you remember we said before that the way we're going to use this, the syntax is going to be like this. So really what the underscore here tells it to do is just to keep on running. Otherwise it would sort of run as a function and it wouldn't keep on running over here. So yeah. Okay, so that's that. I think we're gonna need a couple more though. Fire. I'm gonna call this only stand, and it's gonna include. It's gonna be what we talked about before. This is also gonna include the art proj. Message.sender means that when an account queries this function, like when it triggers this function, so there's a message that's sent to the function. So there's a number of different things in that message object, I guess we'd call it. Don't know if that's the official term, but I'll just borrow that from JavaScript for a second. Message.sender is the address that sends the message. So it's very convenient for checking things about whoever is calling a function. Equals types dot register project. Okay, and then have it keep on going. That also means that type of deleted wouldn't get through. Should I call it only active stand because of that? I think I will. Actually, I think only active is a better name. Only active. Do I have another function that we need here? Not a modifier, I mean? Not that I can think of. Okay. Constructor. Constructor not in the heads? That's an overload. Constructor. Did I spell it wrong? Oh, no. Emit. Create. So this is how we fire off a function. Yeah. Address. So we're calling that as a function, so that it formats the address of the contract. This is familiar from JavaScript. So basically this means the actual contract itself. So once the constructor is called, the contract is instantiated, so it'll have an address on a blockchain, and then the event will fire off where that actually is. And now we'll be using for time for now. Wow, that was a bad pun. Even though it's really not such a good measure of time, I seem to remember that now actually returns the time in blocks. So we would need something to, like, you know, if on a front end, if you actually want to know what time it is, you would need a way of turning the block number into a time. Okay, function create user. So now we're up to our functions. Create user. So we want even people who aren't members of the platform to be able to create a user. That's how they'll get onto the platform. So we won't want only user, only active here. Create user takes a string as an argument. I wonder why I wrote that onto a different line. String public block public name. And this is a public function. Okay, so now we're going to put in some breaking code. So this is why we would need to import the user contract, which we hadn't written yet, but we're still going to put this in for now. So that would break right now because we haven't written that and linked to it, but we got to start from somewhere. Okay, now we push to the users array. What's is user? Is user contract. Do I have something called is user up here? Very strange to me. I don't know what that is. I'm assuming it was something that I wrote and removed. So I'm assuming that's actually a breaking line of code. It could be I'm calling something from the user contract, but I think that's just actually a mistake. So let's keep it up. Let's just skip that. We'll move on to the type of line. Emit user created. That's cool. So message.sender is going to be the first one. User, what's that supposed to be? Oh, the new contract. So that's going to be user contract, right? Yeah. User contract. Name is actually name, and time is name. That should be that. Okay. Let's move on for removing user function. Remove user. Delete would probably be a better name now. Address user. Delete user, right? Yeah, delete user. Let's use consistent naming here. Delete user, address, user, public. Oh, there should be an only owner function, shouldn't there? Or only self. Do I need that more than once? That's probably why I didn't write it. As in, you'll see here what I did is I checked that only the person can delete their own their account, no one else can. So instead of making a whole modifier for only self where require message.sender is the same as the user, so I just used a one-liner here because apparently it's the only time in the contract I use it. So that makes sense. I actually agree with that logic. Hey, it's going good. I didn't think you'd make it because this was just sort of a random stream that I decided to throw on because I had some extra time. Refactoring some contracts. So require message. Sender equals user. So here what we're doing is we're making sure that that only a person can delete their own account. No one else should be able to delete it. So we make sure that that's who they are first. So we want to pop them off the user array. User. And then we're gonna wanna change their type to deleted. Types dot deleted, and then fire off an event for user removed. Which is going to be user and now. That event will tell us that an account got deleted. What's our next one? Oh, you can actually have it so you can create these from here. I think I might skip these for a second actually, because I'm not sure this is really the right place for them. So the basic idea of the platform is that you're going to have users, and then they're going to be able to form communities around something they fund. So originally I was sort of running with Patreon's idea, or Kickstarter's idea, of calling them artists and projects. I've thought about it a lot since then, and I really think that the idea of being able to create a community around funding should exist in a wider sense. Maybe even to say that a little bit better, it's not really just about community also. It's sort of, I guess you could call it a funding app. It is centered around the ability to make make recurring payments to a certain idea. I started off with basically looking at Patreon and Kickstarter, not really understanding why those are two separate sites even. But it's grown a lot. I mean, originally on the Ethereum.org page, way back in the old Ethereum.org days, one of the big use cases was, let's say that parents wanted to give a kid their college allowance, they could lock it up in a smart contract and have it fire off every however long. So I mean, the reason why no one would ever use Patreon for that is obvious. First of all, it's not their branding, but second of all, you'd be paying 8 to 12% off of the allowance for something like that to happen. So it'd just be much more convenient to use PayPal or something like that. But if we're harnessing the power of the blockchain, I figured that means that we aren't restricted to only communities of content creation. Any concept of funding should be able to be used. So I still have this old wording of artist and project. The idea of an artist is that it's recurring, project is sort of a one-time deal. But I've thought I want to change the wording. I don't think I'm going to do that now, but it's definitely something that I want to think about. I want to think about that wording a little bit more. So that is the master contract, though. Let's open up a new contract. We're going to call this user. Oh, I'll capitalize that. User. Now we're going to do a user contract. So I will grab the line. There we go. Contract. User. Should I just call it user, or should I call it user contract? Let's just call it user. Should I put the word contract in there? I did over there. You know what? I actually like that wording. I'm going to keep this shorter wording. I'm just going to call this one master. Call this one user. Could be I should put more words in it there to make it a bit more verbose, but I think this is good enough. User. So address. master. So that's just going to be the stored master address. Oh, I pulled in the whole interface over here. How do I use that? Oh, I have that there so I can query things off of the main contract. So I am going to need to create an interface here. Okay, at the top of master, you'll see this is probably the most important thing on the master contract that we're going to need in the user contract. There's a mapping over here. We have these types that we can associate with any user or with anyone who's on the platform. They're either a user, artist, or project. Like I said, really want to change that wording, or they're deleted. That's useful for modifiers, knowing who can access what functions, who can do what kind of a thing. So we're going to need that inside this contract. So what we're going to need is we're going to need an interface contract. I wish I had a better technical understanding of interface contracts. What they are, from just a pragmatic perspective, is they're the exact same as a contract. So interface for master will have the exact same functions. I believe the exact same modifiers and events also. Could be events don't carry over. I'm going to have to check that up real fast. But it doesn't contain any of the logic. It's basically just sort of like a skeleton of the contract that you're sort of mimicking. By using that interface, you can pull that into other contracts, and it gives the framework that a contract needs to be able to interact with a different contract. So let's just take a quick look. Solidity interface contract. Contract. Should I use them, or should I look at here? Actually, no, I really should just look at the Solidity docs. This is an ancient version 0.5, but using this I can just bump it up to latest. Contract metadata usage for automatic interface. I wonder if it's this. Resources. There wasn't anything that was as obvious as I thought it would be. The metadata is used in the following way. A component that wants to interact with the contract, e.g. Mist, that's ancient, or any wallet, retrieves the code of the content. For those who don't know, Mist was a browser that was created to... calling it a browser is probably a little bit of a stretch. It was an early Ethereum project that worked sort of like a browser that actually had a Geth node running in the background. So it was one of the original ways that you'd be able to connect to the internet using a blockchain. And then, of course, MetaMask ate the world. Okay, that's not as true now as it was at some points. There are a lot of other wallets that are getting very decent market share right now. Actually, one of the key people behind Mist, Alex van der Sand, actually is behind a new project now, Universal Logins, which is actually really cool. So e.g. Mist or any other wallet, or any wallet retrieves the code of the contract from the IPFS swarm hash of a file, which is then retrieved. That file is JSON decoded. Whoa, this does not sound like anything I recognize. I haven't been doing NatSpec on this. I really should. NatSpec is a documentation commenting format that Solidity works with. But I'm sure I do really want to add that to my code. It's very useful for a number of reasons, and it automatically forces you into really commenting and documenting your code in a very, very clear way, which is super cool. But I'm not gonna do that right now. I'm gonna come back around and do that later, I hope. Okay, interfaces are the same as abstract contracts, created by using an interface keyword. Interfaces do not have any definition or any state variables, constructors, or any function with implementation. They only contain function declarations, i.e. they don't have statements. Only the external functions they can inherit from, they can't. Oh, they can inherit from interfaces, but not from other contracts. They can have enums and structs, which can be accessed using the interface name dot notation. Okay, so let's take a look. Interface example. Functions having only declaration, not definition. Contract call. Creating an object. Interface example object. Yeah, okay, so you see over here where he has 3 different contracts. Interface example. Sorry. Interface example. Here it's an interface. Here it's an actual contract. So you see over here there's a function get string, function set value, and function add. Over here, same thing. Get string, set value, add. Same functions. Over here they're empty. All you see in set value or get string are the arguments. It's in your string memory, uint num1, uint num2. Over here, you actually get the you get the logic. Also over here, since these were private variables, so they're not exposed in the interface. Yeah, so get string just returns string. Set value allows you to set the value for those 2 variables, and then add allows you to add the 2 of them together. Now, there's a second contract. As in, we've contracted an interface before, now we have a contract call. So first it creates an object of interface example. It'll be using the interface to do that, if I'm understanding correctly. Then function call, public, object, new this contract. Okay, value. Okay, so first you have to call it in order to instantiate it, I'm assuming. Or to connect it, maybe? I'm not exactly sure. That, yeah, very strange to me that they put that into a function. And didn't just have over here sort of like something equals new, like interface example, obj equals new this contract. Wait a second, what's going on here? New this contract? What's a this contract? Bit confused about their syntax there. Here, in any event, they have a function, calls object get string, then it calls object set value. So here it should return geeks for geeks. Here they set the value at 1015, then return object.add should, or that's a 16, whoops. It should return object, it should return 26. Okay. Okay, so we are going to need a, wait, that should have a capital. And now we're going to need iMaster. That sounds sort of cool. I for interface. Okay. Drag my solidity away. Interface master. Really debate if I'm doing the syntax right. So these are public variables we said do go in, right? No state variables. Wait a second. An interface can have enum structs. So I'm going to need a function in master. Okay. They don't have any state variables. That should mean that, okay, the whole reason why I'm going to need the interface is so that I can access this mapping. But the thing is, mappings don't exist in interfaces. So what I'm going to do is I'm going to create a view function. Function get type. Bring public. Wait, my string address. Not thinking. Address public address. Return type of. And this will be important because I'll now be able to call that in other contracts using the interface. It's interesting that doesn't know view. Am I using that wrong? I really don't think I'm using that wrong. I think the Atom package for Solidity highlighting is a bit behind. Okay, yeah, looks like I'm using it right. Okay, yeah. View means that it's read-only, can't change any state. Okay, interface master. Let's do this. Can have enum. I'm gonna need the enum, aren't I? Yeah, I think I am. Modifiers went in. Can't remember their functions, so it would make sense to me if they do. Okay, so I don't need to put modifiers in. That sounds fine. Oh, there's a whole dev.2 on that. Read that at a different time. Not going to bore you with it. Okay, so where are we? We're making an interface. That's what we're doing. So we're up to constructor. Structor. Function get type. Get type. Has address. Address. We have function create user, right? Create user and delete user. Create user string. And function delete user string address. These two, since they're actually restricted by modifiers, I'm pretty sure that's still the way I write them in, but I could be wrong. I'll have to double check that. Did I change something over here? What did I change? Oh, it doesn't make a difference. Okay, so that should be our master interface. That's really important because that means that over here we can go import and go. Oh wait, no, we have dot read I master dot so. Okay, address master. The question is if I'm using the master interface, I'm not exactly sure how I'm gonna loop in the master address. Oh no, that's not a problem. Okay, yeah, I'm not even gonna walk down through that logic. I just had a thought that was just out there and incorrect. Yeah. Okay, so what are we doing here? Okay, yeah, because I'm over here. Sorry, as I get my bearings. Right, okay, so now I need a master object. No, I'm not doing this right. I need to remember how to instantiate that contract. Interface. Here, when you're doing it through an import. Wait a second, do they have that over here? How'd they do it? Obj knew this contract, but what do we know what this contract does? Contract this contract. There is no contract this contract. Oh, here we are. Contract this contract is interface example. So I did forget to write over here also. Master is. Wait a second. Oh, I changed the name in the wrong one. Oh, silly. Contract master is master. And then I'm going to need to import that over here also. Import master. So, okay, now we're starting to get a hang of it. Forgot that. Okay, now again, syntax. So new this contract object equals new this contract. Wonder if I'm able to do this. I would hope that I'm able to do something like, what would I call this? I would hope that would work. As in here you have interface example, which is the name of the interface. Object equals new. It should be new master. Wait a second, maybe it should be new master. I think I'm getting something wrong here. I'm gonna put this in for right now. Like this, except I have to do that. And I'm gonna have to do a to-do just to make sure I'm getting that right, because I don't think that I am. But okay, enough of that. Enough of that. Right, the user struct. Okay, so what information do we need to store in the user? Or the basic, wow, there we go. The basic relevant information that we need for the user, like the basic profile. I don't know if profile is the right way to describe this. Oh, that's why I called it user contract, because I called the struct user. I'll just call the struct user info. That's okay. We store in a struct. Struct is a custom data type. Basically, it'll just know I can call user or user info, so I just named it, anywhere, and it knows that it should have this information in it. These are like the available fields inside of it. So let's just take this all and dump it in, and we'll go through it one by one. So one is the root. Two different kinds of addresses in Ethereum: EOAs, which are user accounts, don't have any contract data, and then contracts, which do have contract data in them. So the way that we're creating these user wallets or the user contracts is that the user has an EOA. They have a normal user address. From that address, they create a user address, which with the contract and everything, and that is their root address. So it's stored here, as in it knows what address created it. I don't know if that was abundantly clear, but yeah, there you have it. String public name, so that's like their username. These should point to like an IPFS or a swarm hash, as in one for their image and one for their bio information. You'd never want to write that to the chain. This is if they become sort of like funded. They make a page for funding, so then that would be art address, like by followed by, they fund, they like, they follow, and projects. Yeah, I really don't like this artist and project wording. But I'm going to keep it for right now. Yeah, also the I fund, I like, I follow. I obviously didn't know so much about interfaces when I did that. But it actually makes the most sense. I fund, I like, and I follow. Because it's hard to know whether you're looking at a list of people that this user likes or that they're liked by those people. I wanted to keep all of them. Also, a little bit expensive, but for right now, it's the easiest way for me to at least see the way the data is flowing. Also, just in terms of optimization, I'd like to be clear. I don't know so much about optimization, keeping gas costs down. That's, of course, a big thing right now with gas prices being as high as they are. I do figure that what I would like to do first is get working code and then start worrying about actually optimizing it. Do I have a better way of writing I fund, I like, and I follow, as opposed to like by followed by? I wonder why I didn't put a funded by also. Could be because it's easy to scrape somehow. Not sure. Gonna leave that as an open question for right now. Gonna have to come back to it. Events. Okay, let's take these over. Take a look at what we got. Liked, liker, liked, time. Unliked, unliker, unliked, time. Followed, follower, followed, time. Unfollowed, unfollower, unfollowed, and time. I think I probably used those in both directions, but I don't remember. Unfollowed, funded. Giver, recipient, amount locked, epochs, epoch type, and time. This is for how long they're going to be giving for. I don't know if this is the system I'm going to use. It could be that I'll try and do something like implement Sablier. I'm not sure about that yet. Profile edited. That I didn't do that for image also. It's interesting. Cashed out, as in they sent all the money from the contract to an address. And account deleted. Okay. I think, oops, that worked? Yeah. I think I'm actually going to call it now. Let me just revert whatever changes I made here. Yeah, I think I am going to call this for now. I think that'll be my little stream for the day. So, thanks for watching. If I get more into a swing, more to a schedule, I will definitely try and post schedule details and have an awesome one. See ya.